Good evening, heroes and heroines, and welcome to Practising Programming in C, in which we are doing some more stuff on Cinera's conflict file parsing routine. We are resolving variables. And we're sort of going through each variable that we could have to handle and actually handling them sort of individually, kind of. But I think before we do this, before we continue with this that we started yesterday, we've got a couple of to-dos that we noted. One of them is this, which is relevant to kind of what I'm going to do first. Climb the tree up to the main config scope and get the owner's information from there. So this would require us to be able to, yeah, I mean, actually we're just talking about the scope trees, aren't we? So I guess we can actually do this without doing the things I'm going to do. Because we don't have the actual main config available here. Essentially what I'm driving at is performing the pushing people onto the config, essentially. A config can contain persons and projects. We do have an add project call, or is it push project? We've got a push project. Oh, we have a push person. What's that pushing onto? It's pushing onto the memory book. And that's pushing onto the config. Okay, so we do have this. And that's doing the push support as well. Okay, so I thought I might have to write all this stuff, but it seems I'm already doing it. So where I do the config stuff, so where's that happening exactly? Okay, so this might be quicker than I thought. Probably not going to see it because I don't think we print that out yet. It's worth bearing in mind that this is probably getting printed out by somebody other than the actual print config routine. Yeah, it's almost definitely the case. So yeah, if we were to print config, yeah, it only prints projects. So let's do a print person, unless we even have that. No, we don't. So let's print out the persons first of all. So we can at least see that. And person is going to have an ID, aren't they? So it's going to be I mean, this is just a string, ain't it? Yeah. Tell you one thing that I'm missing actually. Yeah, it's a print string, new lines essentially. Because you can see, like, we've got a print string I which takes an indentation. So that's going to print the ID. It's going to first of all insert, it's going to print out indentation, number of spaces, and then print out this. It doesn't print out a new line. Print pair, yeah, whereas things like print pair, these guys do stick on the new line. I mean, I suppose we could just make a quick old no, let's leave it for now. It probably will be nice if we have a better set of print functions that can just do a bunch of stuff like indenting, new lining, and all that kind of stuff. So a person can contain a support. Oh, they got full name, haven't they? So yeah, I think it's similar to this dude here. Essentially, we need to be going over all of the it's not actually looping, is it? It's just it's literally just taking that actual thing. Yeah. So. And a person can also contain, right, homepage. And then it's got the number of supports. So let's print the name in the homepage. And then we want to print the support. And this is going to be just the ID icon URL. Okay. Because we've indented these guys, it might just be nice if we indent that. It's a bit cheesy because it's kind of like it's kind of hard coded, the indentation level. It'd be nice if this was a bit sort of, if it was a thing that could actually adapt to whereabouts you are in a scope. So it doesn't like support. Oh, there's already a print support function, is there? That's fine. Config support. So we've got a person. So this is slightly different, isn't it? A config support. ID icon URL. There's strings. ID icon URL. So they're exactly the same. That is pretty interesting, isn't it? So we don't have... Where is this used exactly? So that's only used by print support, and so print support... Ah. I see. So this is never used. Maybe that's old news. This is the new thing I'm writing. This is the previously written one. And the only place that either of these is called is here, where I'm just writing the new thing. So I guess we just... Like, where's this happening? Like, that's not being called either. I assume that's just test stuff, wasn't it? Because technically, the includes don't end up getting anywhere. You know, like these don't end up in the parse tree, for example. They only exist in the token thingamajig. So maybe that's why this just never gets called. And then the print support function that we've already got up here is taking a config support, and as we've already established, we never use a config support. And it's the same as the new thing. I think because I'm pretty sure that the support is actually being used in more places. Well, it's being used at all, rather. So there's support. Yeah, and the person here contains its actual support. P support is a support. This is our new function, so that's kind of out of the question. True person. Yeah, I reckon just, config support, get rid of this. Might be nice if we do a print support I, and then the whole thing sort of is indented by that amount. Yeah, you see how this is working? It's like it puts the new line at the front, and then finally ends with a new line. I guess it doesn't really matter actually, because still all this stuff is purely test stuff. So do we get any more stuff? We do. So here we go. So we've got Miyatatsu. Name. Shouldn't that be printed in yellow bold? Print person. No, it shouldn't be, because it's not. Should we do them in cyan? So there's Miyatatsu. Name is Miyaakura. Homepage is this. And then we've got the Patreon and Patreon. So we've got icon, Patreon, PayPal, PayPal. I wonder if that is a bit suspicious. We didn't look at the we didn't write the push person, did we, today? Because we already have one. What is this actually gonna be? So the idea here is supposed to be taking these guys are going to be absorbing it. We've got support PayPal here. So here's our support Patreon. Now, where is this exactly? And this, right? I'm gonna print this scope because I would have expected this person to have got I would have expected them to absorb the correct icon and the correct URL. Wouldn't I? Well, actually, it probably doesn't matter because I'm only pushing the person during the resolve variables, aren't I? So as long as I can see that, that's all I need. So it's the push person. Should be quite early on, I reckon. So here we go. Yeah, push person. So this scope tree has got the person's Miyatatsu. And we've got all of this lot. So yeah, we have got that available to us. Support Patreon. So this mustn't be working correctly. push support, isn't it? Let's step 3 push person actually. So there we go, we're pushing Miyatachi 1. So, person, we need to fit the person. True means declare, by the way. So the ID should be resolving the string. I think we were seeing the name and the homepage done right, weren't we? Yeah, we got Miyako. So the person's tree count. Now, that is related to this. Right, the trees within the person's scope are going to be the support and these 2 supports. So there should be 2. There should be 2. So that's received this support tree. So it should be pushing on Patreon sprite poo. So we're resolving strings. We're fitting a support into the person. Currently got the ID is Miyatachi, the name is Mio Irakura, homepage is this, and you can see that this is just the contents of the page of a book. It's currently got no supports. That looks a bit sketchy, doesn't it? Yeah, that's bullshit. The icon in the URL, that's wrong. I need to be passing it's this value. Yeah. Well, it's push support, isn't it? So yeah. That's what I need. push person. Oh, I don't have the thing anymore, do I? Yeah, because it was drawing. It was actually this thing, wasn't it, that gave me the final thing. Well, actually, I think I just need to look for Miyatatsu. Did I build that? There we go. This is what I need to see. I suppose I could do with making resolve variables or print config print out the name of this function. Just so I can easily locate the start of that information. Yeah, there we go. So we now have okay, so we're just missing the person from here. So when we try and resolve this variable, we're missing out this bit of information. Supports are only contained within people, right? These don't actually exist within the config. So let's just go to that resolve. Let's try and do this. It's a little bit slightly in depth because it means climbing scope trees. But I think we should at least be able to, I mean, we need to do it anyway. And in fact, this is actually perfect. It's just the logical thing to do next because we're now pushing on people, which is what we wanted to be doing before moving on to the next thing. So let's see, resolve. This is our main function, isn't it? Resolve string, yeah. Do get config identifier from string out here, resolving the local or environment according to that value. So let's do that first. It's test, isn't it? Also, the resolve local variable doesn't need to take the test necessarily. It could just take, well, it could take like a config token, sort of. So what I mean by that is, Is it just one of these? Yeah, it's one of them. Config pair. So it's a config identifier and a string value. Do we care if it's a pointer to it? Don't think we do, but we can let it happen. Where else is variable even used? Oh, that's funny. This doesn't even it doesn't even need to be a config pair. Because we're only switching on the actual thing. Right, because we're resolving this test string, resolving something like this, well, specifically this, to see if this is a local variable, getting the ID of that variable, and passing that ID to resolve a local variable. Right, so that's the only thing that it actually needs to know. So still got the print config happening up there. So we've come into this support. And we've been asked to resolve this particular string. We found this thing. So we know that this is, we're resolving a local variable. It's valid in support scope. So what's going to happen here? The scope tree that we're in is going to be the support scope. And the support scope doesn't have access to the person's name. Blimey. This canister is almost empty. I must have like churned through a load of these the other day. So it's no wonder I was having digestive dilemma the other day. So when we're resolving this thing here, we're going to be within a support. What are we going through here? Right, we're resolving variables, and what we're doing is we're pushing persons on. So if this tree's ID is a person, so we can only get to that thing. So what the question here is, right, resolve variables is being passed the scope tree. The scope tree is absolutely everything, including the root scope. Right, let me just show you to be a bit more specific about this. Print scope tree happens out here. In fact, if I just leave everything else of happening. So this is the entire scope tree. Starting here. This is the root scope up here. So this is stuff like all of these sitting at the root scope. Then we've got things like support. Right. Now here, this thing will be unresolvable because it doesn't actually, this thing doesn't reside within a person. It's only once you come down to this person here, right? This person which has absorbed this support Patreon into here, that this is available. Right, now when resolve variables does its thing, remember this is going over this is going over the entirety of the root of the scope tree. This is saying if the scope tree that it's looking at here is an ident person. In other words, if it's this, then we push person. Right. It's not touching this one. So it's only ever talking about this. So in other words, what we need to be doing and what we can do when we are resolving this tree here, we just need to climb up to its parent to retrieve the person's name. ID rather. That's all we need to do. But I don't believe that the scope tree actually currently contains its well, it does, doesn't it? It does contain its parents, so that's kind of handy. Blimey, we thought of everything, didn't we? So if I just go here, and if I just do print scope tree, and it's just the scope's parent, and then just sleep for 4 seconds so we can actually have a little look at it. Are we just not setting it? Is that what's happening? Well, mind you, we did get into here, didn't we? Let's step in and just see what that's given us. Resolve local variable. So in the case we get an ident person, so the parent is being set to something. Can I just not do that? Can I if I just resolve this? Yeah, so this is what I'm talking about. Why can't I not print out? What is print scope tree taking? It takes a scope tree. Where's indentation coming from? I might just step into. Well, am I? Yeah, I can just step through, can't I? So we've got a scope parent. Let's step in here. Oh, we've got the. We have been past something that's non-zero. The ID of this thing is ident person. That's right, isn't it? TID. Well, actually, CIDK is ident person here. I guess the type spec is taken separately to track all of the other stuff, isn't it? It's to track whether the fields have been set. wonder what indentation is at this point. So that's 0. Okay. So it doesn't like that. Yield of size 4. So ident null is within this enum here. It's within the config identifier enum, and it thinks that CIDK. So this is a scope tree ID key. So let's look at the scope tree. So that's what it should be looking at. It should be trying to talk about this. Keep use after free. Is this one of those cases where I've reallocated something and it's got lost? I'm not exactly sure I understand, like, why we could be seeing what we're seeing though. You know, we clearly saw that the ID key was set to something. Just run it again. Also, let's just so this is the current scope. It managed to print that. Might be an idea actually to try and print the current scope also, just to see if that dies. Yeah, let's do that. Yeah, let's just see what happens. So I reckon this is actually printed out this. Let's make it actually sleep for us. Just give it a second. Just to see if we can see it. So yeah, there we go. It printed, then it slept. Then it died on the second print scope tree. I mean, yeah, okay, so that is dying as usual. So can I just do like Let's do a couple of sleeps. It didn't like that. Just doesn't like accessing that. So let's try and figure out why. How do we do this? I mean, clearly it's going to be a push scope, isn't it? It's going to be a push scope happening somewhere. Copy scope. Where's push support? Push support is here. Oh right, well that's to do with the resolver. It's really when we're doing the scope tokens, isn't it? Oh, it's is it called something else? Oh right, it's scope tokens, it's just a recursive call. Well, hang on a minute. Push scope. It's probably this actually. What is the else? What is that talking about? If it's an include, then go through that process. Otherwise do this. So let's just try something slightly sketchy. Just increase that to 32 just to see if it still crashes. Which would give us a clue that it's probably crashing because we're resizing the thing. Yeah, okay, so it succeeds, okay. So the problem is, unfortunately, probably, that we're resizing. But I'm still not sure I understand. Why we have access to anything. I mean, in the debugger. Right. This will crash, won't it? When we run to here, well, I just need to dereference it. Right, this is available to us. Is that just kind of stale stuff, maybe? This shouldn't be where it thinks it is. Right, so there's that. Just now set the parent to be that. Oh, hold on a second. Unsigned. Do I have to be trying to print this off as a shorter value? Yeah. That'll be unfortunate if I do. Well, and it also probably wouldn't make sense because, yeah, like I say, this is comparing. This is just doing a comparison. And this ident null, right, as we've already established, is a config identifier. And the scope tree's ID key is the same data type. So there we've got something of size 4. And the complaint is read of size 4. Okay, so he's trying to do the actual read of the correct size. So he's having to push scope. What's he doing? Because we're ending up with the ID. The ID key set to ident person, aren't we? That's what we want to be finding. Well, it's not here, is it? But I think it's ident person is what we want to be looking at. I'm not exactly sure what I should be looking for though. Do you know what I mean? Also, this should probably crash, shouldn't it? If we can't get an ID. I mean, we're doing this check if ID. Oh, I'll tell you what we could look at actually. because what we're talking about here is the scope tree. These scope trees here that we're dealing with are the same scope trees that we're ending up with, and that we're kind of trying to talk about down here. So if we've got an ident person, when we see this print scope tree, we should be able to, I mean, this happens later on, so we'll have to just continue past this actual thing here to get this information. We can print out this scope tree, see who it is, and then see how that thing gets built up. I think that's what you could do, isn't it? Right, because it's this thing here that's failing. The parent. Oh right, yeah, the parent. That makes it a bit difficult, doesn't it? Because really, we want to be looking at how this guy's getting built up. We don't have access to it. Although we kind of do, don't we? Because we can... We can look at it in the debugger. Right. So we've been told that we're talking about the person Miyatatsu. Miyatakura. Unfortunately, actually, we're only ever adding one person, which is kind of helpful, actually. So yeah, I guess we were right before to be jumping into that add scope if the ident is person. Is that true? Because it should be this very scope that we're talking about. I mean, to be more specific, it should be this very setting. So maybe am I just setting this in incorrectly? Maybe what's happening is I'm dereferencing this config pair. Then the config pair is getting blown away at some point. So I really need to be setting the ID and the key individually. Maybe that's what I need to be doing. Let's just try that actually, just as a quick thing. Push scope. It's kind of amazing that I'm only encountering this issue down there. the value is going to be a string, which kind of actually does suggest that when we're doing here, we're talking about a pair. Where's this pair coming from? Oh, that's going to be our issue, isn't it? The pair is only locally scoped. Right. So that's going to be a problem. I think when we push this scope, we actually need to be copying these strings into a book, don't we? Right, because that ain't going to fly. If we... Well, is that true, actually? I mean, the pair is going to be value, it's going to be the field ID and the value.content. What's the value? The value is also just a local thing. Okay, so if dash, you're going to dereference that to be this. Yeah, it still doesn't like it. This is still the same complaint. We decided for the... And as we established, resizing the, allowing us to push on to a bigger thing. Right, if I just change that 4 to be 32, right, so it's bigger. I think doing that let it work, doesn't it? So it seems to be something to do with resizing. Let's have a quick gander, see if that's possible. No. I guess we could like break onto this line and just see what happens when we hit a tree count of 4. Well, I mean, I guess, well, mind you, the fit function is used all over the place, so it would be breaking to push scope. Breaking on this line. Let's just have a go. Oops. Well, I mean, that wouldn't have really been the right one anyway. Parent tree count should be 0, right? Yeah. I guess we could just display that parent tree count. I suppose another thing we could do also to try and determine exactly where we are is see if, you know, where we're doing the sleeps failing. We should be able to print out in the debugger like multiple levels of parents, shouldn't we? So we should be able to nail down a bit closer where we're actually failing. So what? Try to print the scope. Okay. Right. And then the next one should just not exist. Yeah. So we're in the root scope. Which I suppose we'd have to be, wouldn't we? It's 20 trees. I mean, what's kind of weird about this whole thing is that we can print the scope trees no problem. Right? Like, we can go through we can print the scope tree here. So I believe this should actually pass, shouldn't it? We can print that scope tree. We're failing to print the parent scope tree, but well, I mean, we're failing to even print the parent's ID key, right? I suppose maybe we don't know if we can print the scope tree within here. Yeah, I mean, that does it fine. Do you see what I'm driving at though? Because a scope tree can contain scope trees. Right. And the thing that I'm trying to sort of do is operate on a scope tree that's within a scope tree. I mean, in this case, it's the parent scope tree. Let's just see if that's actually true. So can I print the scope tree of the scope tree's first tree? I can do. So there's here. I guess like we could do a 4i, right? Although I don't know that this will be very instructive because it's still gonna, it's just gonna it's just going to work, isn't it? If it doesn't work, then that'd be interesting. But yeah, it's working. And the thing that we're trying to talk about is simply this. Right? We've come into this support here. Well, hold on a second, actually. Where's the sleeps? Yeah, I'm just super bamboozled at this point. Because where we are is... it's going to be in one of these calls, isn't it? What we're trying to resolve is specifically this. Actually, this is actually what we're trying to resolve. We're trying to resolve the URL of the Patreon support. Right. So if we were to step into here, see what the support tree is. You know, just step into here and just like step through it basically. I suppose part of the issue could be that I didn't actually write this function today. I just like copied and pasted it. So it could just be stale and it's just busted. So once we're looking for the Patreon one. Yeah, and it does seem to be the Patreon. So if we step into this resolve string, what else do we also have? We have this. So we've got the base Patreon, icon spec Patreon, icon spec poo. So it's the URL person. That's what we're talking about, right? Yeah, right. Here we go. So we're trying to resolve this. And it was in this call that we were crushing. So we've been passed a parent. Let's just see. We can print the parent. Right, and this person has a parent as well. Add it person. Right. It's this specific value that we're crushing on. Right, okay, yeah. So let's just go through this until we've got the full test. Well, I mean, even so we've got the flipping ID. Right, ID person. So we know what we're trying to do here. Is that we're trying to resolve the person. And then here's our fanciness. what G is. Maybe uninitialized. Yeah, I'm just super bamboozled as to what is going on. And I've got no real idea as to what it could potentially even be. Because all we want to be doing here is going up to the parent and just getting this value, right? Well, more specifically, we want to be getting this value. That's all we're trying to find, and copying this value into our book. But when we go up to this parent, this print scope tree call fails. And in fact, this trying to we can find we can find this, okay. Right, we can find the size of that, no problem. But if we try and print that out or test on it within print scope tree, it just doesn't like it. Right, you can see that this is yeah, we are within that scope. I think it was literally doing this, wasn't it? It was this check it didn't like. Is that the right way around? I mean, just like print pair. I mean, this is what I wanted to do, wasn't it? It's print pair. The ID. Oh, hold on a second. Well, actually, yeah, that could be right. Pointed to a print pair. What about the address of? And more specifically, it was actually this test, wasn't it, that was failing? It was the CIDK. Right, so we've got a TID, we've got the T rather. shouldn't it? Yeah. Before it got to sleep. I don't know, dude. Like I say, it does seem like it's something to do with resizing, because when you do a push scope, right? I think, was it like 20? Was it 20 scopes that that contained? Now that succeeds. That dies. This is succeeding. So yeah, I mean, it seems to be completely linked to the resizing. So maybe when we do this fit, we need to port everything over to the new thing. But again, I don't know why other things haven't started to fail. Do you know what I mean? Parent trees. By the looks of it, this could also initialize the new dudes to be cleared, couldn't they? Because these are essentially doing all of that. But that won't affect how the actual stuff is being changed, I don't think. I mean, if that changes anything, that'd be super weird. It doesn't. Parent trees, size of points to parent trees. Or other parent trees dereferenced. Fate is going to use the tree count modded with this number here. To determine if it needs to fit, if it needs to expand. I think I might need to mull this one over. I think I understand that it's linked to resizing. But I don't understand why. I understand how it could be linked to resizing if we have pointers pointing into this thing, because that was the thing where the situation we were faced with the other stuff, which prompted us to introduce the idea of memory books and pages that you allocate, and pages that don't resize, they just get allocated and you just write into them, and pointers into those bits of memory remain valid. We don't have that situation here though. Because a scope tree is only ever, I mean, if it's pointing at anything, it itself is pointing outwards. It's not that people are pointing into this scope tree. You know, like this string here, for example, has got a base and a length. So that's pointing out to somewhere else. Yeah, exactly, it's the config pair. And this config identifier is just a thing that's right there, you know. So maybe I'm just misunderstanding how reallocating is working. That's the only thing I can really go on. I'm misunderstanding how it's working. But also, I'm also clearly misunderstanding like how other stuff doesn't seem to be failing. The contents will be unchanged in the range from the start of the region up to the minimum of the old and new sizes. If the new size is larger than the old size, the added memory will not be initialized. So yeah, that's what I'm saying. The contents will be unchanged in the range from the start of the region. The contents, that is. Not the actual kind of memory addresses, right? Because those can change, but the contents will be unchanged. which is what we want. And it was breaking. Right, that works fine. So our theory is that it's linked to the resizing. And we also can't, like, I mean, I guess we could trigger a check after doing the fit, couldn't we? Because you remember how it was failing. It was actually, it's dying on a particular call, isn't it? It was dying on this call here. We could probably somehow perform this check within push scope. I wonder if that so hold on a second. Could I print out the tree count, for example? Would that do anything? Well, I mean, we know that this fails. We know that this succeeds for some. Yeah, I mean, this could succeed anyway because it's just a pointer, so that could. It doesn't matter at all. Right, yeah, so it's failing. So I just can't access that at all, it seems. But, like I say, if I just CGDB it, I can totally do it in the debugger. Right? I mean, I know that I'm printing it as an LU. Maybe that could have been the problem, actually. Well, no, because the tree count is a long on site. Right, 64 bits. It's a long unsigned. It's a long unsigned and it's accessible. Right. It's 2. But if I step over this line, it's just not going to like it. Because of this. Heap keys after free. It's located 280 bytes inside of this region. But as I say, that ain't a pointer, is it? Oh shit. Oh. Oh, dude, actually. No, but still though, like, why can you still access the scope parent? Because I was going to say, like, you set somebody's parents, and then that parent scope gets re-allocked, rendering this pointer invalid. That could be what's happening. To be more concrete about that, it's like in scope tokens. Right. You do a push scope. So you know, you basically push onto the parent scope a new scope, and you set the new scope to be the current parent. In pushing on that scope, you set the parent pointer to be equal to the parent, the incoming parent, and you return the new parent. When you encounter a pop scope, well, it's this actually. When you do this, that is probably the problem actually, isn't it? We're going to do this to pop up to our parents. And then we're going to continue to process the parent. Right. We may have to do more push scope calls on the parent. Or I guess technically it would be this parent's parent. This parent's parent. And that person might have to, that scope might have enough push scopes happening to that it needs to realloc. Right. But when that reallocs, that's going to move the pointer of, it's going to move the location of this grandchildren's parent. Isn't it? That's probably what's happening. So probably what I have to do I need some way. Jesus Christ, it's gonna be the memory book all over again, isn't it? Really, I don't want to be reallocating. I probably want to have like a memory book style thing happening for this, happening for these scopes and these pointers, simply so that this particular pointer can remain valid all the time. Because the alternative would be, right, if you fit a tree, if you need to reallocate this, the alternative would be going through all of their parents and offsetting their pointers. Sorry, going into this dude's trees, right, as in child trees, and offsetting the parent pointer of all the its children. I reckon that's what's going on here. I'm not doing this now. I'm gonna stop now. But I think this is our problem. Yeah, so to fix it, we have two options. When resizing, well, right. Well, it's not even that, actually, is it? Loop over the trees. It's like offsetting the tree's parent pointer of each tree's tree. Right? When reallocating, loop over the trees, because we're allocating this, right? Parent trees. Well, hang on a minute. So yeah, the parent is already coming in. So just imagine this is a grandparent coming in. We're reallocating the space to fit the grandparents' children, which is our parent, right? Yeah, the grandparents here, we're reallocating the pointer to each of its children. All of that stuff remains valid, but what is invalid is the children, is the parent pointer of their children, right? Because those parent pointers will be set here. and don't get moved. Right, so this will be set. That the parent's pointer gets reallocated, rendering this invalid. Yeah, that makes sense to me. I don't know if that makes sense to anybody else, but that seems to make sense to me. That might not be too difficult, actually. Should we just try it? We could try doing the offsetting thing, couldn't we? I don't think that should be too tough. Should it? Because we're talking about this pointer here. We're talking about getting a diff between that and the new parent trees. And then going over the tree count of this thing here, and just going over that, but then going into the children of those people, offsetting their parent pointer by that value that we just computed. Let's give it a go. I'm not sure that I will stick with this forever. It might be, because you see what I mean, it can get a bit troublesome when you just end up like sort of, I don't know, just offsetting all this crap all the time. You need to always bear in mind like who's going to be pointing into things, and could that potentially get wiped out? Could that potentially getting invalidated? You know, if you have to keep considering that sort of stuff and accounting for it, it sort of makes more sense to come up with a better way of doing it, which seems to me like it could be like the memory book fixed page allocation style. So is this even going to work so far? Yeah. Okay. So Yeah, and how it fucking works. And that was simply because I'm now offsetting those pointers. Yeah, that dies. No, it's okay. So yeah, I don't know. That shouldn't be unsigned, by the way. It should be signed because it could go before. I don't know. Not sure exactly what to make of that. I think push. Well, I mean, I don't know. I don't even know that. I was going to say I think push scope is the only thing where I actually have pointers to parents. But that might not be true. It sort of makes sense because the scope is a thing that can contain scopes. And I think it's the only thing that can contain scopes. Or rather, a scope is the only thing that can contain one of itself. Oh, well, mind you, we've got push project, haven't we? Push project can push projects onto itself. So what is this going to be pointing to? I think the push project is only going to be pointing to. Yeah, I'm accounting for this actually. Push project is going to, when you see like a push, when you see the owner, this, right? When you see this thing, what you're supposed to do is go up into the main config and find all of those. Find all of the people. So, like when you do the resolve variables, right? What I'm talking about is each project is going to be pointing into this little piece of information here, right? So we've got a config contains this. It contains a pointer to persons and a pointer to projects. Inside the project, there is a pointer. There is this pointer here, and there's also pointers to pointers, right? So there's multiple pointers. So these pointers will actually be pointing into a person struct. Well, it'll be pointing into this person struct here. This person, this array of person people, right? And I think that's all that will be happening there. And the way that we've told the resolve thing to happen is to actually make that available first. So when you do the resolve variables, right, it goes over the people first, sticking all those dudes into the config. Into well, where's it going to? Oh yeah, it's going to this result here, which is a config. Right. So they will be pointing into that. And the other pointers we have will be... Oh, right, yeah. So we might end up actually... Is that being called by push project onto project? By chance, by any chance? Yeah. Okay, push project onto project itself calls push project. This thing is going to have a default medium, right? And the default medium is going to be pointing to, yeah, again, right, you see, when we push a project, we loop over the mediums first. I'm not sure exactly what this is doing again. Did I sort of realise that that was bullshit and forgot to delete it? So what does it need to actually contain? Let's have a look at the projects again, just very quickly. I am sort of wrapping up here, by the way. I'm not going to do any more. So there we go. Multiple. I mean, these are multiple as well, but you can sort of determine that anyway. So yeah, we're going to be pushing the mediums on, and after having done that, we then loop over the default mediums. The other things that we're looping over is simply everything, isn't it? Sorry, it's trees, isn't it? What other trees do we have in here? Yeah, we don't have any other trees that we care about. Because like I say, the persons are actually going to be pointers. So the way we configure them is under risky, we see the owner is Miyatatsu, right? This is going to come in as an actual string, right? So it's going to be, and a string is a pair, it's just a regular pair. So we should see within the, within this, yeah, within this lot, this is going to be pointing into the, configs, the main configs list of persons. So all that means that now we should finally actually, well, we did see it, didn't we? Because we were finding that this couldn't happen. And also, I'll tell you what, the reason why the print scope tree would work is that it's only dealing with children pointers, right? We're never actually following the pointer of parents. So that's why we never spotted that. Because the pointers that we were using were always valid. Oh, interesting. Hold on a second. DRY. So we're never getting there, are we not? Should we not have got to there? What are we printing? There's the print. Maybe we just printing out too much stuff and it's not fitting in the back buffer. doesn't like that, does it? Oh, I think I know, actually. You actually need to go up a further scope, don't you? Probably. I mean... yeah, we're never getting there. If scope parent... Now, is that just not working because we've now invalidated some parent pointers and they're just straight up not showing up? What's going on? We should be getting to the resolve variables at least, shouldn't we? Resolve local variable. Oh, it's probably just again because we're just losing the stuff. Oops. Right, Jesus. Yeah, the problem there was we just didn't have enough back buffer to actually print the dude. So there we go. We're home and dry. So all that means is that we've located the person that we want. So I guess actually resolution is what we want to be saying, isn't it? It's like resolution. Right. So what we're looking for is the the person. We're seeing if this person's support URL. Well, it's not exactly that, is it? Because I think that gets stomped somewhere, wherever Mio is. I think we should be now seeing after all that the Mio's Patreon support URL should actually just show this, have this replaced with Miyatatsu. And yeah, you can see that it does. So after all that, we've finally got this little bit of information coming through. And now that we're clearing, right, clear this, I don't reckon we need to bother doing any of these guys because it's simply handled by this. this ID setting seems to be correct. Seems to be what you want. Now what I'm going to do is, I'm just going to do, in fact I think I might just augment this to do here. Yeah, I mean, I drove offset pointers, and it'll also just save us the work of doing offsetting the pointers. You know, going through each child, child, and offsetting the parent pointer. Yeah, I think that should cover it. So we're not sleeping anymore, which is fine. Push scope was what we were just talking about. Resolve internal variable. Resolve local variable. That's nothing. So yeah, finally we've got resolve local variable. Correctly doing this. And also let's just do a quick to do here. Do we need to like go up multiple parents? Essentially, do we need to send through multiple generations? Because we're not at the moment. We're just going to the parents and seeing if the parent is who we need, and if they are, then using it. Otherwise, we're just like, we're off. Yeah. And I think, like I was saying the other day about stuff like this. I think we want to make this generalizable. Oh yeah, and also check if it even exists. So yeah, we've got to do all this kind of stuff. But not now, because we've done enough today. Basically 2.5 hours. And we had a long exploration of what was going on with the parent stuff, the parent pointers getting invalidated. But it was worth doing, I think. It was kind of bamboozling, but it was good to actually figure that out and then try out the solution and find that the solution worked. We always like to do that. And there'll hopefully be some more of that in future episodes. So thank you very much, Heroes and Heroines, for tuning in and for being fantastic and inspirational and beautiful. Until we meet again. Farewell for now.